Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So I'm going to make a semi-brief, hopefully, video outlining the simulation again, which is still being worked on. There's a couple of bugs in it still, but I'm going to explain the simple function and the fact that it really does duplicate charge, which duplicates gravity, which, frankly, is going to explain everything. And such. So there we are. So I have made it, I think, as visible as possible. And so you can just basically see some of the simple rules, but it's a very weak amount of force, and the whole point is this ends up being very consistent. I didn't think of this ahead of time, but it's very consistent with what we see, in the sense that atoms are less and less stable the more free space they're in, so to speak. The less force containing the nucleus, the less capable it is of staying together. And so all of this stuff is made inside the sun. It's under a lot of pressure. When it's finally released, some of it isn't going to survive. The fact that it's being depressurized, essentially. So all of the functions become more and more, the rules become laws, okay, the more pressure the system is under. And so let's just do that part first. We'll just go through the simple rules, and that should explain a lot. All right. So as I've pointed out, there's only two kinds of force: electron force, proton force, and two kinds of matter: protons and electrons. Neutrons are just a combination of a proton and an electron stuck close together. All right, and there's only three interactions. So the first interaction illustrated is an electron force hits an electron, and if the electron is going in the same direction it's going, or it doesn't have any momentum, any direction, then the force bit is absorbed, it sticks essentially, and what you get as an output is a matter bit being pushed by a force bit. Now if it already has a force bit, then it's going to be going a little bit faster and faster. So the speed of light force pushes a matter bit, some percentage of the speed of light, let's say 10%, and you just keep adding percentages. So if it has one, then it's 10% of the speed of light. If it gets a second one, well, then it's 10% of what's left over, which is 90%, which will be some kind of 80%. So it can never go faster than the speed of the force. All right, the second interaction would be the force bit, the electron or proton, is moving against the force bit. Then you have a perfect reflection. The force bit reflects, and one of the previously collected bits of force repels. So this sort of gives you the illustration here of the fact that no matter what hits the Earth, it always, even if there's a reflection, it always puts more pressure on the Earth. So the pressure on the Earth is always going into the Earth. So if the Earth was over here, you can see that both, whether it reflects or it absorbs, the Earth ends up feeling the pressure. All right, the third interaction is kind of simple. If a proton force hits an electron, or vice versa, and it doesn't matter whether it's moving or not moving, doesn't matter what it's doing, it just gets converted into the force of the matter bit it hit. So it just goes straight through and changes color. Changes from a proton bit of force to an electron bit of force, or vice versa. So with those simple three rules, it will, I would argue, pretty much perfectly duplicate what you would expect from charges. So we'll put the simulation back on, and we'll play with it a little and increase the amount of force. So this is a tiny amount. Obviously I can add a lot of force, and I can change the radiuses of the force bit, so I'll do that so they're not quite consuming, and you'll see that pretty quickly it tightens up. It makes neutrons, essentially. So electrons and protons end up combining pretty strong. And the stronger I make the force, the stronger that bond will become, and the harder and harder it is for it to be by the little bit of chaos that might be in the system. So there's less and less chaos, the more, just like with any probability equation, the more permutations, the fewer irregularities, and the more regular it becomes. And basically it'll just start creating the geometry of what you would call an atomic nucleus. Okay, you start creating the elements that'll make that possible. Now I can change the number, so we could go with 4. Let's say we should do 4 reds and 2 greens. So that would represent the constituents of a helium nucleus. 4 protons and 2 electrons, which is the same as 2 protons and 2 neutrons. So the idea is to just recognize that neutrons are just the first dipole, the only true dipole, in the sense it's a very clean dipole. One end is decidedly north, one end is decidedly south. All the other magnets you can create won't be that clean. So when the magnet says NS on it, it really isn't purely north and purely south. It's just that it has more north at one end and more south at the other end. But it doesn't mean that it's pure. That's why magnets come in such a variety of strengths, is because they aren't perfect dipoles. And it doesn't start getting interesting till you start creating the super cooled substances and start creating a cleaner magnetism, in the sense that there's also no vibrations inside the magnet, and without vibrations it becomes a cleaner and cleaner magnetism. But anyway, I don't want to get, it's not really about magnetism yet, but I'm just saying it has, the building blocks are there. The atomic nucleuses are made out of these objects. They're in rigid positions once they're in a nucleus, and once they have a geometry, they don't go, there's no orbits, there's no swirling about, there's just jittering. And it explains why the core of heavy objects is hot, is because all this force is being pushed towards the center, and there's a real tug of war. There's no such thing as cancellation. So regular physics has this idea that somehow you can cancel two opposite directions, and you can't cancel them. If I take steel balls and I smash them together and I don't allow them to reflect, they create a bunch of heat. They don't cancel. The force is still there. You can't destroy the little bits, and you can't destroy these matter bits, and all of the motion has to be conserved. All of the motion has to be conserved. It doesn't matter its direction. Key point, really, that physics has missed. So anyway, you can see it just creates what might be called a deuteron. These two of these deuterons make a helium nucleus. So once you start putting this stuff together, helium nucleuses can travel through space without being dragged to a halt. The electrons and protons can't travel through space without being dragged to a halt, so it's clearly demonstrating that, yes, there is drag, but there's a trick to drag, okay, and the sense is that the helium nucleuses has the key to that trick, and the trick will probably have something to do with the fact that, it's once you create one of these objects, they can have a position to each other, and you can flex that position, causing them to be more energetic in a direction, so they can compensate for the drag. But anyway, no point in getting way ahead. I'm just demonstrating the simulation works. It's really simple. I've won the Occam Razor Award. Nobody's going to come up with a way that creates the phenomenon of charge with simpler objects. There's no pulls anywhere. It's all just pushes. There's no magic forces. They're all just, you either absorb momentum, you reflect momentum, and you just have a transition state where it's hardly beyond our comprehension to understand that you could push something through something and it would change its form. So not magical at all. I think that's probably it. I'll just keep it brief and short, but it clearly works. It clearly does model charge, which has remained a mystery to conventional physics, and it does it with a mechanical, physical system. A system where you can see it, you can draw it. There's no gluons, there's no puons, there's no magical bits doing any magical things. There's no waving things, there's no wobbling, except what you would expect, which is there's a bunch of force hitting from both sides, and at any one moment it will be a little more force one way than the other way. And that jitter is the heat that melts the center of the earth. Alright, so probably enough. Made my point. I can't do logic and reasoning for you. So if you're going to just ignore the fact that it works, it's simple, and it's physical, I can't do much else. So go ahead and be a religious kook. Because frankly, that's all the conventional theory is a bunch of made up, fake, Holy Ghost style, authority-ish mechanisms that are all just poofed. They all have no physics to them. They have no mechanical structure. They're not physical. Okay, so go ahead and believe your mystical physics instead of real physics.